Hi, check out this question from Further Mathematics WAEC 2017. Without wasting much of our time, let's solve the solution. The next step would be to talk about the foundational knowledge which we need to have in possession before we solve this problem, and that's the premise. And the first premise is algebraic expansion. You need to have a good grip on algebraic expansion. As you can see what's written on the board, we are going to try for different premises or different scenarios, and it is expected of you that every item in the first bracket multiplies every of the item in the second bracket, as you can see. The next thing you have to do is a square minus ab plus ab minus b square. And as you can see, the middle term or middle expression is negative ab and positive ab, which gives you 0, leaving us with a square minus b square. Then the second premise is going to look similar, but in this case is more like a perfect square, where we have a plus b all in the bracket, a plus b all in the bracket. We are going to follow the same steps as we did for the first premise on this one, but this time around the outcome is a little different, where we have a square plus ab plus ab plus b square, which at the end of the day we have a square plus 2ab plus b square. Now the next thing we have to do is to rationalize. Let's rationalize using conjugates. As you know, whenever you want to rationalize, whatever you're multiplying the Surdic expression with, you have to do it for both the numerator and the denominator. And this time we have an expression which would find its conjugate and then multiply it for both the numerator and the denominator. So the problem in first place is 1 all over 1 minus root 3 squared. Now its conjugate is going to be 1 plus root 3, and since the denominator is squared, you have to do the same for its conjugate, and this time around you do it also for the numerator. So as you can see, we have for the numerator a perfect square. We are going to invoke the second premise which we discussed earlier, where we have, as you can see, 1 plus root 3 raised to the power of 2. And if every item is meant to multiply every of the item in the second bracket, it's going to give you an outcome of, okay, let's finish off for the denominator. For the denominator, you already know about the indicial law, where two terms, all raised to the power of 2, can be enclosed in a bracket like this. All right, so the next step is going to be 1 times 1, 1 squared. Then we have 2 root 3, because 2 root 3 appears in two places by virtue of multiplying 1 twice. And then we have root 9, which is a perfect square. Now the next thing you also handle for your denominator. For the denominator, it's a difference of 2 squares. And then we have like the first premise, that is the essence of those premise. This is difference of 2 squares, and then we raise it to the power of 2. Now we're already on the last lap. For the numerator, we're going to have 1 plus 3, because root 9 is equal to 3, plus 2 root 3, all over, as you know, root 9 is equal to 3. 1 minus 3 would give you negative 2, and then you can raise it to the power of 2. The simplification of the numerator is done, and then for fraction like this is how you break it down. 4 goes for each of the items in the numerator. And then 4 divided by 4 gives you 1. And then 2 over 4 is the same thing as 1 over 2 in its equivalent. And here, folks, is how you solve this problem. So let's check if the options are made available, if the answer is made available in the options. All right, and that's answer B. See you later. Bye. Of you who might not have understood what happened there, you need to have a good grip on algebraic expansion and sorts. And moreover, I've been offering virtual courses on subjects like physics, further mathematics, and mathematics for secondary school students. So, in case you wanted to join and learn some of these things for yourself, I'm always a chat away. Check out the contact link below my flyer. Bye.